In this video, we're going to be analyzing a transistor circuit. Now, there's a certain rhythm to transistor circuits, and once you get into the hang of it, they're really kind of easy and almost fun to calculate. So what we have to remember is this. Our VCC minus 0.7, assuming a silicon transistor, gets you your VRB. VRB divided by RB gets you IB. IB times the beta, gain or amplification, gets you your IC. IC times RC gets you VRC. VCC minus VRC gets VCE. So I'm going to walk through all the steps here. You don't be expected to memorize all of that right now, but let's put some values to this. So right now we're dealing with a 36 volt source. We've got an RB of 15,000 ohms, and then we've got an RC of 125 ohms. And in this case, our beta, or our amplification factor, is 95. So our first step is always this. We have to assume that we're dealing with a 0.7 volt drop across the BE if we're dealing with a silicon transistor, which 99.9% of the time we will be. So we take that VBE of 0.7 and we go 36 minus 0.7 will give us our VRB. In this case, that works out to be 35.3 volts. Now we got enough information using Ohm's law to figure out what our IB is. We're just going to take the VRB divided by RB to get our IB. So we do that, and it calculates out to being 2.35 milliamps. Yes, it's small, but it is significant. So now what we're going to do in this case is we're going to take our IC, we're going to calculate that out by going IB times beta. In this case, it's going to be 2.35 milliamps times 95, our amplification factor that was given to us right there. And that works out to be 223.25 milliamps. So we've amplified the current, which we really haven't. We've just used a smaller current to control a larger current. So now we have the 223.25 milliamps on our IC. We can take our IC times our RC to get our VRC. So if we do that, we end up with 27.9 volts. That leaves us with one last calculation. We know that we have a VCC in this case of 36 volts. We know that we also have a VRC of 27.9 volts. We knew that on this branch here, we would have a total of 36 volts. So it was this voltage minus, it was VCC minus 0.7 gave us that, because this voltage has to equal 36. Same thing on this branch. So what we're going to do is go VCC minus 27.9 volts to get a VCE of 8.1 volts. And that's it. That's our walkthrough. So again, just to walk through it again, VCC minus 0.7 gives us VRB. VRB divided by RB gives us IB. IB times beta gets us IC. IC times RC gives us VRC. And VCC minus VRC gives us VCE. Done.